Hi there. So for the beginning part of this unit, we did systems. We did systems of equations to find a point that two lines share. Then we did systems of inequalities where we shaded multiple lines. We graphed two and then did shadings. We are now going to do what's called optimization or linear programming. And so what's going to happen is this. You are going to be given, or figure out from a word problem, three things to graph. And so that you've got these three things to graph right here. So let's look at them and graph them. Y is less than or equal to 5. So here's our 5. There's our line. Y is less than 5, and it's going to be everything below that. I'm not going to color it in yet. You're going to kind of see why. And you might not want to color everything in right away. The second one is x is less than or equal to 4. So here's 4 right here, and here's this one. And it's less than. So we've got this, and we've got this that we're kind of talking about. The third one is y is greater than or equal to negative x. So we could sometimes maybe, if we need to do an XY chart, we can. And so we would get that. Negative 1, 1. This is what that line looks like right here. And it's y is greater than or equal to. So that means it's going to be this side of it. So what you've got, everybody, is when you do three lines, you are going to get a triangle. And the points that we are going to be discussing and looking at are these 3 points where, and you got to make sure you draw the lines right, where do they cross? Where are the vertices on this? So the first thing you're going to do is graph the 3 lines. And then you'll do a shading. Once you've done that, the question's going to be find the maximum and the minimum optimization of those lines. For when you have this situation equals 5x minus 2y. So what does that mean? Find the max and min. Well, what you have to do is, what are the 3 points? This point here is negative 5, 5. This point is 4, 5. And this point is 4, negative 4. So what do we do with those 3 points? What we do with them is put them into this expression. So the expression is 5x minus 2y. So when we have negative 5, 5, plug this in for x and this in for y. 5 times negative 5 minus 2 times 5. 5 times negative 5 is negative 25 minus 10. So, when we have this point, negative 5, 5, the result will be negative 35. When we have this point, 4, 5, let's put that in. 5 times 4, because 4 is the x, minus 2 times 5. 5 times 4 is 20 minus 10. When we have this point, the result is 10. And I'll even write those in a little bit right here. You get 10, negative 35. Now let's do the last point. 4, negative 4. 5 times x is 4, minus 2 times negative 4. 20 plus 8 minus a negative 8 equals 28. So this point gives us 28. The question was, find the max and the min for this function. What's the maximum that was produced? Right here, 28. At this point. What's the minimum that's produced? Negative 35. And those are the answers to this problem. It's a little confusing. And what's going to be even more confusing once we get to class on Thursday is that I'm going to add a word problem to this. Is that machines can make certain types of juice. And maybe one is something less than 5 per hour, and something is less than 4 per hour, a different one. And then we have this represent. So all three of these inequalities are going to represent a situation in a word problem. So what I'm going to do is we're going to practice just graphing these first and doing max and mins during the first half of class on Thursday. And then in the second half of class Thursday, we are going to start to look at word problems and how they fit that. And then your homework Thursday to the following Monday is going to be doing some on your own. So be prepared for Thursday to the Monday after that you'll have worksheet type homework problems related to this. But you've got to be able to graph the three things. That's the first thing that you have to be able to do, is graph these inequalities, do the shading to get this space. Okay, because this is the space we're talking about, this triangular region. I call it optimization because it's going to be a situation where the question isn't find the maximum or minimum, just random numbers. It's going to say, find where the maximum amount of apple juice and prune juice can be made in one day. And you've got to then figure out situations here. Okay, and we're going to work on that Thursday. So be prepared to come in and do this for your practice on Thursday at the beginning of class, because this is the basic skill to do. Okay, so fill out the Google form. That's the homework on this, and I will see you Thursday.